Hi everyone, welcome to NCK Hub. Today in our video we are going to cover selection sort as part of data structures and algorithms. So what is selection sort? Selection sort is like a comparison based sorting algorithm. So smallest value among the unsorted elements in an array will be selected and then inserted into an appropriate position in an array. So what is selection sort algorithm and how it works? So basically array is divided into two parts like sorted and unsorted. Initially sorted array will be Initially sorted array will be empty and then unsorted array is a like given array. Sorted array will be in the left side and unsorted part will be on the right side. So uh, first smallest element is selected from the unsorted array and placed at the first position, and then second smallest element will be selected from the unsorted array and then placed in the second position. Like that, based on the number of elements, like this process will continue until array is sorted. So what is the time complexity for this selection sort? So best and the worst complexity case is order of n square. So now let's see how selection sort algorithm works. Yeah, so first we are going to get the given array and then we'll get the index positions I, n and the position. So I is called we are going to iterate the array. For that purpose we are using this I element. So where n is the length of array and POS is the position, finding the element. So whenever we find the smallest element in the array, then we are going to swap with that smallest number with the that particular position. Suppose if we are searching in the first element and then we are comparing with the other elements. So if smallest element is found in the next unsorted array, then we are going to replace or swapping the both the values. So this is how this loop is going to continue based on the number of elements in the array. That's how we are going to exit. So how we are going to find the smallest number in the array. So first we are going to uh, set the small number as the index based element. So for example here it is array of I. So and then we are initializing one position, so that is also index I. So and then we are iterating from I plus 1 positions to length of an array. So like that we are going to repeat that loop, and once if we get the smallest element from the loop, so and then we are going to swap both the elements. So that is how we are iterating the elements and we are ending coming out of that loop. So let's see with the one example like how it actually works. So suppose my given array is within a size of 7, okay, and these are my elements 13, 28, 26, 7, 31, 16 and 42. So if you can see, now I am considering 13 as my first element, and then I am comparing with all other elements in the array. So whenever any smaller number occurs than the first element, then I am going to swap both the elements. Okay. So here 13, I am considering 13 as the first element, and then I am comparing with all other elements 28, 26, 7, 31, 16 and 42. So if you see from the other elements, I can see 7 is the smallest number. So when I compared with the first element, so 13 and 7, so 7 is smaller, so I'm swapping both these elements. So now my first element is 7 and fourth position element will be swapped to 13. So now I need not to iterate this first element. So this is already sorted. So now what I need to do? So I need to take the second element of the array. So currently my second element is 28. So and then now I need to compare this 28 with other elements of array like 26, 13, 31, 16 and 42. So if any number is uh, smaller than 28, then I need to swap the both the elements. Okay, so yeah, so this actually iteration is going to continue till the end of the element. So till this point, so we are going to check the number. Okay, so once the unsorted array loop ended, so then I will swap the numbers. So now I'm going to swap number 28 and 13 positions. So however, like second element now I got it as 13. So now if we take the third element, so that is 26. So now 26. Now I need to compare with the other elements on the unsorted array. So with 28, 31, 16 and 42. So again I found like 16 is the smaller number. So again I'm going to swap both the numbers. Okay, like now my third element is appearing as 16 and then 28, 31, 26, 42. So now next I'm going to move to next index position like fourth position. So that number is 28 and then I'm comparing with the other numbers 31, 26, 42. So again I found like 26 as the smaller number than 28. So again I'm going to swap both the elements. So now fourth index I'm getting as 26 and then 31, 28, 42. So now I'm going to take the element fifth from fifth position. So that is 31 and then I'm comparing with the other elements. So I found like 28 is to be the smallest element. Again I'm going to swap these elements. So now my fifth element is like 28 and then 31, 42. So like this you are going to compare your position element with other unsorted array elements. So like this is going to be continued till we reach the end of the array. Yeah, so what is the time complexity for this selection sort? So if you take any case best, average or worst, so it's going to be order of n square. So whatever the size of the array or number of the elements, so you are going to iterate for every position with other unsorted array. So whether it is a best case or worst case or average case, so this is time complexity is gonna be the same. So best case is like there is no sorting required. Even though sorting is not required, still you need to do the comparison with all those elements and then iteration will continue. So average case is like when the array elements are in jumbled order. So that is not properly ascending or descending. So then that considered to be the average case. And worst case is like all the given array elements are to be in reverse order. Suppose all the elements are in descending order, but I am trying to sort it based on the ascending order. So even in that case also, so complexity is same. So coming to space complexity, so it is like an order of one. So for swapping the elements, like I need to use one temporary variable. So that makes the space complexity as order of one. Yeah, so now let's see with one sample example from programming. So how it gonna work. So this is the sample program selection sort demo. So based on the algorithm, so whatever we have discussed in the slide, so we have developed the code for that. So Yeah, so I have initialized one array like with elements 85, 56, 8, 19, 14 and 24. Okay, I'm creating an object for that class, and then I'm trying to iterate print the array elements. Okay, so before sorting, and then okay, so for displaying the numbers, sorry, for displaying the elements of an array, so I have written one method like print array. So it's nothing like just iterating the array with for loop. Okay, so passing the array as an input parameter, and then initializing one variable I and getting the length of an array and iterating that array using for loop, and then printing each element. Okay, and then I'm calling this selection sort algorithm. So how we developed, so we are passing the array as the parameter, and then I am initializing three variables of integer type I, j and the small. So I is for outer loop and j is for the inner loop, and small is like to identify the index position. Okay, so where my smallest number is there. Okay, so this is my first for loop. I equal to starts from the first index like 0, and then I iterating till array length n minus 1, and then iterating with I plus plus operator, incrementing operator, so that I will be increasing my index positions, and then just printing the which iteration is this. So that first I am going to take that my whatever element, so that my smallest element is available in the first position. So that is 0, and then I am iterating from the second index to the end of array. Okay, so j equal to I plus 1 and j less than n j plus plus. So this is inner loop. So here I am comparing the element of this is a of j is like second element, whether my second element is less than first element a of small. So this small equal to I, it is holding the first position 0. So I'm comparing a of 1 whether a of 1 is less than a of small or not. So that means my second element is less than first element or not. If it is less, then I am making that my smallest number is in position j. Like this is getting the index as j. So after ending of that inner loop, so if further any smaller element is found, so your smaller number position is going to be changed. Okay, then I am using one temporary variable to swap the numbers. Okay, so once I found that smaller number is there, then I am going to swap those positions. So in temp equal to a of small, so temp I am storing the a of small element, and then a of small I am assigning a of I, and similarly a of I equal to temp. So now my elements are swapped, and I am again printing the array. So yeah, how each iteration my array elements are changing the positions, so that we can get here. So once we complete everything, so end of the execution, so after sorting I am again printing the array elements, so that finally we are going to get the sorted order. So now if we run this, so before sorting, so these are my elements 85, 56, 8, 19, 14 and 24. So when it comes to first iteration, so my smallest element I am considering as the first position. So that is 85, and then my inner loop is going to iterate from 56. Okay, and then it is going to compare 85 and 56. Okay, so 56 is smaller compared to 85. So now the position will be same, like this is the smallest number, and now it is going to compare like 56 and 8. Okay, so yeah, so smaller position initially for first iteration you will get at 56. For inner loop again you are going to compare with 8. So again my smaller number is 8, so that smaller number index position is going to change. Okay, so now that is 8. That means 0, 1, 2. So my small position index position will be 2, and then 19. So like that it is going to be compared. So 8 with 19 and 14, 24 like that. Okay, so still 8 is the smaller one. So then I'm using this temp to swap the elements. So like this, after first iteration we can see this smaller number came into first position and the other elements are same, 56, 19, 40, 24. So for second iteration I'm going to consider like smallest number is 56, and then I'm going to compare with these values. So I got 14 as the smallest, and then just swap these positions, 14 and 56. So second iteration, after second iteration, so these are my elements. And after third iteration, so this 85 third position is compared with the other three. So it is found like 19 is the smaller one. Interchange these two elements. So 19 and 85 are swapped. And after that, 85, compare 85 with other two elements, 56 and 24. So again you can see 24 is the smaller, so just swap these two elements, 24 and 85. Okay, so now last element is 56, so compare 56 with 85. So 56 is smaller than 85, so no need of swapping. So elements will be stay as is. So after final sorting, so I'm just printing that array elements. And similarly we can give the large data set as well. Okay, 99, 85, 74. So that is like this is in descending order. Okay, so even for this it is going to take the same number of iterations, like index size is 9. So size length of an array is 10. So maximum iterations will be 9. Okay, sorry. So just run this example. Yeah, so you can see number of iterations is 9 iterations. So after 9 iterations, you can see like my array elements are sorted. Okay, so 2, 17, 26. So it is like in reverse order, 2, 17, 26, 38, 44. So this is how selection sort works. Thank you so much.